The first place to start when looking at laser beam propagation is with a simple Gaussian beam propagation. And if we go to the Analyze tab in ZMax and look under Lasers and Fibers, we'll find there the Paraxial Gaussian beam calculation. Let me just put this over here. Now, what is this telling us? Well, first of all, I've started off with a laser, helium neon laser from the CVI Meles-Griot catalogue, and I've entered all the input data that I know for it. So I know what the beam location of the waste relative to the output port is, and then after the output port of the laser, I've just put a piece of glass 5mm thick, and I want to come to focus over here. Now, if I look at the Paraxial beam settings, I just need to set this up to be the data that I got from the manufacturer. This is the size of the waste when it's this distance away, and so you can see that by the time it hits the output face of the laser, the beam has expanded from a radial height of 1.15 to a radial height of 1.25. So there's been some expansion of the beam as it propagates. The rays themselves just go in a straight line and don't show any propagation, don't show any divergence. So what I want to do now is optimize this lens for the best Gaussian beam performance, and I'm going to define that as saying that I want the smallest beam size over here. So I'm now going to go to the Optimize tab and click on the merit function editor, and it comes up with a pre-built merit function GBPS, Gaussian beam size, on surface number 5, which is this surface. Using the beam waste data that I got from the catalogue, I want to target the beam size to 0, and if I simply call the optimizer now and start, you'll see the merit function drops very quickly, and exit, and the beam size has dropped down to about 8.3 microns, and you can see that that's the size of the beam here on the image surface, and the size of the waste is almost identical to it. So there's only a very small shift from the beam waste to the surface. So that's a very straightforward Paraxial Gaussian beam calculation, and it gives us things like beam size, beam waste, positions, and phase radius of curvature. But what it really doesn't give us is any idea of the aberrations introduced by the lens into the beam, and that's what physical optics is for, and we'll look at that in the next video.